She walks in behind him. Yes. Oh my gosh. So it's like that when they come home. It's just I say the next year. So I'm like, okay, then I'm like, oh. Then I'm like, I don't It's like simple and it's black and it's like,
Alright, time please. So we're going to talk about standard deviation today. What it means, how to find it. So I just kind of printed them up for you guys. If you don't like it when I print them, like I know some people probably want them in their notebook. Some people will probably like it when I print them. I don't know if you have a preference one way or the other strongly, let me know. Anyway, standard deviation was in the summer work. So what? It was sarcastic. Standard deviation is the kind of the definition of it is the average distance from the mean. Basically, what it means is like how spread out the points are. So, yeah, one of the main ideas I want you to get out of today is that if it's a bigger standard deviation, the data is more spread out, like further away from the mean on average. And if it's a smaller standard deviation, the data is less spread out, like it's more compact. It's all kind of clustered together close to the mean. So I put a couple examples here. So like you all know people that are like really moody. You kind of never know what you're going to get from them one day to the next or 1 hour to the next. And some people, those people would have like a high standard deviations in their mood, because they can swing from like, oh, I'm in a great mood to like screw you at like the drop of a hat. I've been known to do that here and there. A lower standard deviation would be like someone that you just kind of know, like no matter what the situation, they're kind of always the same. Like they're just pretty low key, like even keel. They don't get too high or too low. That'd be like that person has a low standard deviation in their moods because they're always pretty similar moods. They don't have like these drastic swings. Does that make sense? The difference I'm trying to say. So I put temperatures out here too. San Diego's, I mean, the temperature changes a little bit, but basically they don't even have seasons really. Like the temperature is pretty much the same all year round. They're really close to the same all year round. So it's always like 60s, 70s, maybe sneak into the 80s a little bit. So, you know, the temperatures are all pretty close together. That's a smaller standard deviation. Where in Milan, you know, we got seasons, so it could be 0, and even in the same season. Like, you guys have been here when it's 80 one day and like 40 the next, you know? So that's like a bigger swing back and forth. That's a bigger standard deviation because the data is more spread out. Does that make sense what I'm trying to get at? Let's look at this. Students in my integrated math class, the grade that they are in, small standard deviation or big? Like really tiny, right? They're all 11s. So that's a standard deviation of 0 basically. Ages of people at, okay, which one has a bigger standard deviation? Ages of people at Simon's or ages of people at a random restaurant that you go to? Did I say bigger or smaller? Bigger. Okay, the restaurant's bigger, right? You're gonna have like kids, old people, like everything in between, whereas Simon's is like a smaller, like they're all kind of clustered together. Make sense? Okay. So, here's like a list of, I just made these up, but let's say these were the high temperatures in San Diego over the last 13 days. I want to find the standard deviation. So first find the average. Add them all up, divide by 13. 79.5? So I'm going to make this table. You don't necessarily have to make the table every time. But I'm going to make a table. I'm going to list the values over here that were given to me. In the next column over, I'm going to put how far away that value is from the average. And I don't even care if it's positive or negative, because the next thing we're going to do is square it. So if the value were negative and I squared it, what would happen to it? It'd be positive. If the value is positive and I square it, it's going to be positive. So technically, you can do, well, I guess it doesn't even matter. I just want to know how far away each point is from the mean. Bless you. So like this is 1.5 away from the mean. This is 1.5 away from the mean. So go ahead and do that. This is the distance from mean. Look at those crunches. I was like, do you like float? Like a jetpack? That's awesome. That looks cool. Yeah, that would be sweet. Some of you do this in your head. Some of you might want to use a calculator. Not sure which one I am at. You should have those numbers, I think, if I'm doing it right. So we're just going, okay, how far away is that point from the mean? What? Where? Oh, yeah. Alright, then we're going to square all those. So I'm going to take every number that's in this column here and square it. You can kind of make your life, so I know 1.5 squared is 2.25, so I can find all of the 1.5s, which there's a lot of, and put 2.25 in all those spots, instead of doing that like 6 separate times. Then you're going to add all those up. Yeah, it's 85.25. Questions on the process yet? Are you guys with me?
Yep.
So we found the distance from the mean, squared it, we're adding all those up, and now we're going to find the square root of that total divided by how many there were. And that is your standard deviation. So it's 2.56 is your standard deviation. Hold on. Yeah. What do you mean? Oh, geez. Okay. Thanks. You leaving? Okay. So we'll just finish the packet. We'll do a video again. Yeah. Hold on. Let me get his question. Yeah. Not really. Like, it's not really used for anything. So you divide it by the 13 and then you square root it, and then that's what means something. David just asked what the rounding rule for the AP test is. This is a good question. That's a terrible answer. So they say, like in AP Calc, it's like rounded 3 decimal places. Clear as day, you know exactly what to do every single time. In AP Stats, they say round to where it makes sense. Which, yeah, is an awful. So, like, there's people that are just refuse to round. Like, there was a girl 2 years ago that she would have given me this test and she would have written this. She was just like, screw it, I'm not rounding. I'm not going to get around. Like, and that's like, I can't argue with that. So I have no problem with that. So, I mean, round to where it makes sense is a really tough, like, I don't know what that means.
If there's like a 5, you want to keep rounding.
I don't know, because what makes sense to you and what makes sense to me might be two different things, you know?
I mean, is there ever an instance where you wouldn't run the 3?
Here, I would keep this for sure.
Well, I mean, what would they mark you wrong if you did 3?
Yes. That's rounding too much. Your standard deviation, you want it to be pretty precise.
No, but I mean an extra decimal. 3 decimal.
Oh, I thought you meant make this 3.0.
Oh, no.
Okay, yeah.
And I can't think of an instance where that would.
No, like, if you're going to make an error, put more decimal places than less. Any questions on the process anywhere? Dwayne, you good? So this column here is the, like, how far away these are from the average, right?
Yeah.
Then I took these numbers and squared them, and that's how I got these.
Okay.
You okay then?
Yeah,
Okay. So I just want to look at, like, what would happen if I changed one number. And we're not going to, like, do the whole thing. But just to give you an idea, like, if I made this a 25, did I just increase or decrease the standard deviation?
Or increase.
Remember, the more spread out they are, the bigger the standard deviation is. So didn't I just spread this data out more by putting this 25? So if you just think through the calculation, wouldn't this be like a much bigger number now? Because this is how far it is away from the mean. So the mean will change a little bit, but this will still be really far away. And then when I square it, this will be much bigger. Which means when I add them up, this will be much bigger. And then when I square root it, this will be much bigger. So when I put a data point that's really far away, it's going to make the standard deviation bigger because you spread everything out more. And then you can see that in the math too, because all that would change as we went through. All right. Questions on that process anywhere? So on the next page is Mylan. Do that one. It's 13 days of temperatures in Mylan, so we got a 55 in there, we got a 90. Wild times. What? Is that going to be a higher or lower standard deviation? Higher. Is that what you said?
Were these consecutive days?
I just made them up. I don't know.
Could be.
They could
Well,
be.
they were
Yeah.
real, like, sound real.
Would you feel better about them if I said they were real? Yeah, they're real. So did you guys get 72.07 for the average?
Yeah.
I would just do 72.
Okay.
That's fine, yeah. I'm just using the numbers that are already there as my chart. So up top, I'm putting like how far away it is from the average, and then I'm gonna square it right that like below the number.
60 is not 8 away from 7.
Yeah. See, some people should use calculators. You guys with me? You see what we're doing? Sarah is. At least we got that. Is everybody done yet? It goes faster when you don't worry about if you're correct or not. Then you think 72 minus 60 is 8. What'd you put for 1 squared? Oh. Obviously 7. I don't know why you would put that here. .46. Uh-oh.
What was all of yours added together?
2021.
147.
What'd you get for yours?
12.16.
At 12.7.
Yeah, this is.
Let me check what I put in.
Where? Calculator does. We're here a lot of 12.1s.
12.16.
Yeah.
Well, in the general.
12.15579.
I got 12.
Oh, wait, that's with-
60368.
12.1 ish. Fair enough.
Actually, round
What'd you get?
12.2, but
12.7?
what was your like total?
20.
I got 12.46. I got 1921. That's me a longer one.
Instead of getting 289, I got 4,000.
I got 2021 for total.
So did I.
Yeah, I got
For 13, you had a
Yeah.
It should be 1921.
Yeah. 1921 divided by 13 and then
Yeah,
square
I
root
got
of it.
1921.
So it's 12.156. If you're off by a little, like if you're close, you know the process. You just made like a math mistake, you know, which is not great, but in the end, your calculator is going to do this for you. So I'm not really worried about a little math mistake. Questions on the process for that one? How many got 12.156 or something reasonably close? 12-ish, 12.7, 12. I mean, okay. You got a question, or you just still? Yeah.
So like when they test it, like when you're doing these, do they prefer you to like draw graphs or you draw that one?
No, they're okay. Look at these two down here. So I got SAT math scores in AP Stats, SAT math scores in integrated math. Which of those two do you think would have? So remember, everyone takes integrated math. And if you're in AP Stats, you're probably in that group of like, I'm probably a little better math student. Which of those do you think will have a higher standard deviation? Integrated math, right? Because they're more spread out. Like you get the kind of the lower end and the upper end all mixed in one. Get with a partner. What do you do each one, and then just like compare at the end?
I'll take the first one.
Yeah.
If you made like a graph, you get the limits on a test.
That's not really a graph. It's just showing your work.
Well, if you have a test, you have outside.
It's not going to hurt to label it, but you know you wouldn't have to. So all the questions you guys are asking about, do I have to show work or whatever, in about 5 minutes I'm going to show you how to do it in your calculator, so you'll never really have to show work. Yeah, it's annoying to do. But just know how to do it. Helps you understand like what you're finding, you know. You heard me say like just do one, have your partner do the other one, right? Like you don't have to do both. At some point this just becomes like overkill. That's the calculator got up there. Someone has left my class while I was teaching every hour. transfer, but in league, like, while I was teaching.
Listen, anyone's listening.
This looks so bad. No, it's
How we doing? How many got the number they're supposed to get? How many are still working?
I got it way
Way wrong?
20 off. Well,
That's-
I did the steps right, so I must have spent that's pretty cool.
That's not way
20 off is pretty far off.
I know.
I'm 14 off now.
You're telling
On
me.
the second one.
Like, you have 82?
Yes, 82.22.
And you can't open yes, you can.
I published it. I mean, I did it all by hand, so I guess.
I was making sure I typed all the numbers in right.
What?
I typed my numbers in right, so. I trust the calculator more than I trust your
Yeah, it's very
in your head.
Hey, what should trust you doing it in your head?
So, it must be
I don't know about that. Yeah,
what did you get as your mean?
the top one?
Yeah.
Hold on.
That might be where it started.
593?
That's where it started. Alright.
What'd you get?
530.
Interesting.
It can't be.
Alright.
It looks like I can't even.
So your standard deviation's like 81? It's like bigger?
87. Like, I'm gonna redo that.
Okay.
I
The
can't.
bottom one's still big.
Yeah.
See what that
I'm missing my
True.
mistake.
What?
I'm missing my mistake. I don't see that.
Which one are you on?
Second one.
What's
First
your
one
mean?
is-
What's your mean?
My mean is 511, sorry.
Yeah.
Alright, I'm getting
And my distance is. Shut off.
first summer after college.
You swear them?
Yeah.
Yes.
It's easier just to do it. That's 94 bucks.
Like ruined your heart.
96.90.
Oh my god.
96.09.
676.
It's like doesn't even take it. Great, bro. I'm just happy to know. So
that's not the right Did I miss one?
This
Yeah.
one.
Let's do it.
Alright, are we okay? Questions? Just on like the process? Quiet, please. Alright, so again, like just a couple big picture things, like which one, does it make sense to you why the integrated math would be a higher standard deviation? You got like all levels of kids in there, so it's just more spread out. If, let's say I took these AP stats scores and I knocked this 590 and I was like, oh wait, this person really shouldn't be in AP stats. Turned out they got like a 200 on there. What would happen to the standard deviation? Bigger or smaller? They get bigger, because didn't I just spread out the data more? What if this integrated math one, so the average for the integrated math was 511, I believe?
Yeah.
So this 380 is really pretty far away from the 511, agree?
Yes.
Let's say that I was like, oh crap, I screwed up. That's really a 511. Did I just make the standard deviation bigger or smaller? Smaller, because I compacted the data, right?
Yes.
Okay. Get out your calculators. Let's go through and do it in there so we don't have to worry about like typing it in wrong and making little mistakes. Because your calculator does do these. So go to Stat, Edit. That's the button. All right, people lost already.
I'm kidding.
Maddie.
I'm kidding.
Oh my god.
Okay, okay.
Stat, Edit, and then let's do the myelin temperatures. Let's just all do the same ones so we're making sure we're. So do the myelin temperatures. So type in those numbers. You got those in your L1 Slack?
Showing work, but like, if you like miss one number, then you like using credit for like showing work and
Yeah, in general. They would never make you show your work on standard deviation though, because they know your calculator does it. But like, in general, that's how it works. You got them in?
Yes.
Alright, hit stat again. Go to for calculate. How many variables do we have? 1 or 2? No, we don't have 13 variables.
Oh.
13 data points. How many variables do we have? 1. The variable is temperature and myelin. So hit enter on one variable stats. And then some people's screens look different here, but basically you just want to hit enter. Just leave, if you see this, leave everything blank. Some people pop up with like parentheses. Just hit enter. And it gives you all this crap. This number here is the standard deviation we're after. This is a sigma. This 12.155 is standard deviation we're after. We got 12.15, but if you remember, we said round up to 72. So that's why ours is a little different than like the technically correct one. But how many got 12.155 here? You got an issue?
No, I just want to know what the wood red button is.
So if this is all the data we have, it's like the bottom one is we're pretending this is the population, like that's all the data. The top one is if we have like a subset of the population. So we'll get into both those as the year goes on. All right, I want you to do one more. I'm going to write down the IQs of the people in this classroom. Let's see, looking around here, 70,
This is solid 5.
40, David, 10. Let's just use those numbers. I don't really care what the numbers are. Let's find the standard deviation of those numbers.
120. The 180 is here, right?
No, I'm the 40.
And I'm the 10.
Yeah.
That's the first.
55.988.
Eddie, you did it right.
I did.
Throw
All
it
by
up.
myself.
Throw it up.
I am.
We're very proud.
Thank you.
You probably heard me enough from me.
What'd you do?
I came in on time today.
Like he thinks he gets an award for that. Like, how many got 55.988? All right, do one more. Do the SAT integrated math ones. Just try to kind of get it into your brain a little bit. Are there any questions I can answer? The integrated math one. Somebody already did it. Now you're checking, like, did you actually get it right? So the answer's up there. It's like 96.38. It's rounded to where I think it makes sense. I don't know what. 379. I think the rate's good. We getting it? We good?
Yes.
All right. Turn to the next page and try it. I want you to try to do all these problems. There's no calculations here. It's more just like kind of just like the idea or the concept of it. Try these. We'll check it over hopefully before you leave and get you out of here with no homework. They're working on their alphabet. What?
I was just thinking the ABCs wrong.
Yeah. AP Stats Remix. It's the best lesson I've ever given in standard deviation. You should know.
Thank you.
Good job.
See, now that deserves applause.
What makes this the best? Yeah.
Because
The,
we're the best, obviously.
I did a more thorough job. Like, if you got the last page right, well, I did a good job. We'll see. But I haven't, like, emphasized that understanding as much as I did today. And I think it went well. We'll see. If you put, like, DCAB for the first one worst, I gotta recalculate everything. What'd you put? No, what did you put for the second one? Yeah, it was like that. What about the third one? say the first one?
Lowest between highest.
Like, what did that even mean?
Like, I put it next to like,
Oh, and that was like in between.
Yeah.
Oh, gotcha. All right. All right. Are we good? Are we done?
Literally hit the same exact.
All right. Quiet, please. Shh.
Like, I copied and pasted them.
Shh. How many had A, D, B, C for the first one? Nice. Questions? How many had A, C, B for the second one? Man, I did such a good job. How many have A, B, C? Is there anything I can go over? Are we good? And then this would be all staff has a higher standard deviation than just females. Mountain area schools has a higher standard deviation than just the middle school. And then this last one, if I put a new data point at 30, since that's so close to the mean, it'll make the standard deviation smaller. 300, since it's so far away, it makes the standard deviation bigger. Questions on any of this stuff?
Is 30?
What?
Is 30 the mean of that?
Yeah.
So, what did you just say?
Nope, because you're going to divide by 6 now instead of divide by 5.
I didn't get that one.
Oh, I got you.
He loves you.
Alright, no homework. We'll just keep rocking tomorrow.